of gravity actually doesn't work completely. When you start dealing with larger masses, it starts to break down. There are examples to why it doesn't work, such as Mercury's wonky orbit. Mercury's orbit was inaccurately predicted by Newton, yet with general relativity, it makes perfect sense. Albert Einstein created this theory that worked with things like Mercury's orbit. Prior to developing his theory, he discovered some amazing properties of the universe. He discovered time goes at different rates depending on your point of view. With general relativity, he showed that time goes at a slower rate next to large masses, such as planets. Although the difference is minimal, time goes slower next to our Sun than it does on Earth. This has been scientifically confirmed by the use of extremely accurate clocks, known as atomic clocks, placed both on the surface of the Earth and at high altitudes. Albert Einstein's theory of general relativity is a theory about the relation of gravity to the fabric of space-time. The fabric of space-time is a four-dimensional fabric. There's the three dimensions of space: length, height, and width. The fourth dimension is time. We cannot perceive this dimension, only feel its effects. Rather than having them separate, the idea of the space-time continuum is that all four are combined in a four-dimensional fabric. And this fabric makes up our entire universe. The theory of relativity states that everything is relative. Things such as distance, movement, and time are all relative to the observer. There are some things that are absolute, but before the theory of relativity, there were a whole lot more absolutes. Every object, or everything that has mass, causes a dip in space-time. A planet, for instance, creates a big dip known as a gravity well. The bigger the mass, the stronger the gravity. The Sun creates a huge gravity well. In this gravity well, the planets circle around, forming our solar system. This is just the bare bones of the theory of relativity. The mathematics involved are beyond the scope of this presentation. Things we take for granted now, we wouldn't even begin to understand without Einstein's theory. We wouldn't know nearly as much as we do about the universe and our solar system. And the answers that we already have, we may have still been searching for today without Einstein's theory. This theory is incompatible with the other great theory of the 20th century, quantum mechanics. Scientists are trying to alter general relativity to fit with quantum mechanics. Thank you for watching.